Hey everyone, so in this video we're going to be talking about physiology before exercise, how it changes, how we anticipate exercise intensity, and whether the changes in our physiology beforehand actually impact the performance. So this is going to be reviewing a paper that I read the other day, and in this study what they essentially trying to look at is something called pre-anticipation. So initially before we exercise, or at the very onset of exercise, we get an increase in our heart rate, we get an increase in our breathing rate. And this is thought to really help deliver oxygen in the very initial parts of exercise, so that we don't get a oxygen debt, or that we don't have a anaerobic kind of debt in terms of our need to supply our body with high levels of oxygen. This can alter massively in individuals, to the extent where individuals can have a real high anticipation, whereas others can have a low anticipation. And I often saw this with people who have dysfunctional breathing. So in my career as a respiratory and sleep scientist, one of the main things that we do to look at dysfunctional breathing is put people on what's called a cardiopulmonary exercise test. And that essentially gets people cycling or running at a incremental pace to increase the intensity until they can't go any further. And we measure all the variables like oxygen uptake, CO2 output, heart rate, rhythm of the heart, the ventilatory efficiency in terms of how much oxygen is being taken up and CO2 is being delivered out. And from that we can look at fuels that are being used. And one of the things that would generally happen with people with dysfunctional breathing or chronic hyperventilation is the pre-anticipated rise would be very, very high. And that's important because we're going to talk about in that moment and how that could potentially affect your performance. Anyway, back to the study. What did they do? They took recreational athletes, I believe it was around about 12 of the athletes, and what they did is they took them through this incremental test first to see how much level of fitness they had, and then they took them through 4 different routines in terms of experiment 1. Experiment 1 was at 0% of the capacity, so they were just literally sat there for the whole period. Then they took them at 50% of their maximum capacity, 75% and 85% of maximum kind of capacity in terms of the watts that they were doing on a bike. They only exercised for 2 minutes. However, there was an anticipation phase, which was 10 minutes countdown leading up to that exercise. And they measured heart rate, they measured breathing, and they measured all the different variables. Then they did another experiment. They wanted to see whether actually having no anticipation at all versus an anticipation affected performance. So what they then did is they essentially took individuals through the same experiment where they only had 5 minutes of a countdown followed by 2 minutes on a bike. And then they told them the next time that all they were doing was be resting. And what they did is at the very last minute, they literally said, hey, look, actually, no, the session's changed. You need to jump on the bike. Right now, you're on the bike. You need to get going now. So it is removing that kind of the moments of anticipation leading up to it. And what they discovered is that the greater the intensity, the greater the heart rate, or the higher the heart rate in the anticipation, the higher the breathing rate in terms of anticipation. The breathing depth didn't change with anticipation. However, there was a correlation between the intensity of exercise and how much these increased. When they then came to looking at the aspects of whether no anticipation versus anticipation in the exercise, whether that had an improvement, there was actually a 14.8% improvement in time to exhaustion in the individuals who had the anticipation. So what does this suggest? It suggests that our body does in fact prime us when we start to exercise. It primes us by preparing our physiology, by changing our breath rate, by changing our heart rates, and making us more efficient at delivering oxygen. However, in the study, what it did show is that those who had a high level of anticipation and those who had anticipation versus the non-anticipation group actually had lower oxygen kinetics. What do I mean by that? Well, the amount of oxygen that was being delivered to the muscles and being consumed on average across the time period was a little bit lower. But that didn't impact their overall performance. So what does this suggest? Well, it suggests that in this group, those individuals were more driven by their heart rates and also maybe their mental psychology of central command. Central command is basically motor cortex, the part of our brain that sends a stimulus to muscles to contract. They may have been able to produce a higher level of power that wasn't related to oxygen in the long term, or the difference in the oxygen wasn't significant enough. How does this actually happen? Well, within breathing, within the association between oxygen and carbon dioxide, what we call the biochemical aspect of breathing, down at the muscle cells, we have a relationship within the blood and the muscle cells. When oxygen is in a high level and CO2 is in a low level, oxygen actually displaces CO2 out. So at the lungs, this is preferable, because it means we're going to get great gas exchange efficiency at the level of the lungs. So we're going to get oxygen carried into the blood. However, at the level of the muscle cell, where oxygen kinetics or delivery is going to occur, we have a higher level of CO2, generally. That CO2 then forces the oxygen out so that it can be delivered. This is a concept called the Bohr effect, and Patrick McEwen wrote about this extensively in his book, The Oxygen Advantage, and this is what it's based around. However, in those individuals who had a high level of anticipation, their VE or ventilation was a little bit higher. With some individuals, the CO2 was a little bit less, particularly in the pre-anticipation versus the non-anticipation trial. The pre-anticipation trial had a significantly lower level of carbon dioxide in their blood. So therefore, this Bohr effect wouldn't be as efficient as someone who didn't have an anticipation. But that didn't affect their overall performance in this case, meaning that they were still able to deliver as much oxygen or to gain power from central command or muscular contraction or force than other means. But this isn't the case for everyone, because this is also a learned behavior, and it also has a lot of meaning and extraction to it, because it's an emotional, psychological driven thing. There's an example of this that Brian McKenzie over at Shift Adapt actually looks at, and there's an example of, in the World Strongest Man, one of the major competitors, before he is actually due to go and compete, I think it's in the finals, I think it might have been one of the last events, if not his last event, you can see him really revving himself up. Now, we don't know whether this was planned, whether it was learned, or whether it was just because there was so much meaning to him having to win that he blew off CO2. And if you actually look at his performance, he fatigued and gassed out very early. Because when we hyperventilate, we drop CO2 levels, we constrict vessels, we don't get oxygen to the working muscles. The chloride shift and the change in the sodium-potassium channels within our muscles actually alters, and we get more acidity and we get more likely to have cramping. This is what happened to this individual. I will try and find the clip and post it up here. So the case in point here, what am I trying to say? Those who have anticipation, as long as their breathing is functional and it's conscious, then they are more likely to have a higher level of performance. However, if individuals are highly anxious or highly emotional or desperate to win, and their breathing alters more than, say, they would do in training or in other competitions, then that could be at a detriment to their performance in this situation. So overall, pre-anticipated rise or pre-anticipation in our physiology can improve our performance, but not at the detriment of it being excessive, especially with our ventilation and our breathing in situations where there is a high emotional attachment. Something to be aware of. If you like the video or have any questions, subscribe to the channel, drop a question below, I will answer you back, and I look forward to delivering the next one.